Yes, please.
Okay, so thanks to everyone for joining this afternoon. And so the idea here is to coordinate across the projects in the Next Generation IoT cluster for Horizon 2020 projects, focusing on standardization. So we want to be able to share perspectives and have some joint discussion on recommendations for future work. And then we can share this across the projects and with the cluster itself. And so we have an agenda here. I guess this is slightly flexible, but the key thing here is to be able to introduce each of the projects and then to see highlight the priorities for the topics for discussion for the last period. And what I've done is to create a Google document so you can have some shared editing of the notes or the meeting notes. So rather than to try and get a good quality note, so as you making your questions, you're providing your inputs, please consider putting some materials directly into the document so we can make that as thorough as possible. Then after the event, I will clean it up and make it available. And so I'm going to come back to the agenda in just a moment. So that there's lots of potential areas for standardization. And I don't want to go into the details of these, but there are far too many for us to discuss in a reasonable time. So we're going to have to focus on what things are particularly important across the projects, where we feel we kind of some joint recommendations. And what are the best areas? And here's some sort of suggestions to thought. Which technologies and standards we found most useful. So that's sort of saying these things work really well. Our recommendations on that. Where we've had to innovate beyond the existing standards. How we can recommend how to counter the fragmentation arising from the confusing array of standards and standards development organizations, because there's still a lot of that's friction of just slowing the uptake of the IoT. How do we identify winners and losers in standards and technologies? And what kind of abstraction frameworks might help to counter the fragmentation? So that's one sort of thought. Then there's the issue of what kinds of standards. So just being slightly provocative here, some standards are hidden behind paywalls. How much of a barrier is that to adoption? How can we encourage a fluid exchange of perspectives across the communities? As an example, at W3C, I'm trying to organize a workshop to bring people from the NGSI, Web of Things and RDF communities together. That will be for some time next year, maybe towards the summer. I'm not sure at this time. And then which venues should we be seeking to use to exploit or recommending, given that some projects like TERMINET are coming to an end? Because this year, IoT Week was cancelled, unfortunately. But we're hoping it will take place next year. So maybe we could think about some joint activities and sessions for the cluster next year's, which I maybe in Berlin. I think they deferred it to Berlin rather than changed. And then there's the AITI or an Edge Cloud, sorry, EU Cloud Edge IoT.eu, and which is fairly new. And I'm still trying to learn more about that and how it will work in practice. So with that, just go back to the agenda. And is anybody with any questions at this point? Okay, so can we paste the link to the minutes into the
We already did this, Dave.
Okay, cool.
I believe that anyone can access the minutes now.
Excellent. In which case, I guess we can move on now to Simon and to present. Is it right, or is it Jerome? I'm not sure. I think it's. I'll stop sharing.
I'll start up. So, and then I'll also, Jerome, you'll see that I'll also set the stage a bit, introducing the scenarios. You see my screen, right? Okay, perfect. Can you also
Not
see
yet.
my browser
No.
window? Because I might.
Not yet. It's
We don't see. We don't see your screen.
Just a white screen.
My thing.
You're the man in black.
So please tell me as soon as the sharing is there, because my thing says it's shared already.
We are seeing a white screen. I don't know.
Actually, we don't see anything.
I'm resharing now.
Still
and I
no.
hope that at some point. Joe, right? Come on. So I'm sharing a different screen. Now you see a different screen.
Still black, I'm
Not from my
afraid.
side. Still black.
Okay, that's new. Now I'm sharing a specific window, and I hope that the specific window sharing works. Does the specific window sharing work? This works.
I'm afraid it's still black. Maybe you have some other permissions to set.
Not here. Oh, seriously? Okay.
Oh, there's something.
Success.
Yes, it works.
Wait, what do you see? What do you see?
The presentation, IntellIoT
With a big heart.
with a heart in the middle.
Yeah.
Okay, so this wait, so this means we have a delay of about 5 minutes now. Because I shared this 5 minutes ago. Oh, come on. Okay. So Theodoros, please advise.
It worked. Now it stopped. Can you try one more?
Yes, I am doing.
Yeah.
And you should
That's
see
it.
my.
Good.
Now
What?
it works.
Now you-
Now it works.
Ah,
Okay.
okay. And if I now click next, then you see it now.
Yes.
Yes.
Perfect.
Good. Okay. Thanks.
Okay. You
People,
can start.
sorry, I'll catch up. So as you can see, IntellIoT loves the W3C Web of Things group. In the IntellIoT project, what we've done is we've been using a lot of W3C Web of Things thing descriptions. So we've been using a lot of the Web of Things working group. Our goal was to integrate web-enabled industrial devices with autonomous software systems. Okay, and I'll show you a bit of this. These were the people in this, or these still are there different companies in this project. And in the following, I'll show you two use cases: the autonomous agriculture use case and the industrial manufacturing use case. And then I expect that Jerome will also talk a bit about specifically about the agriculture use case, because this is quite interesting there. This is an autonomous tractor in the scope of this project. Here's one of our robots in the scope of this project. We have by now successfully integrated this stuff. So everything that I'm showing you here, yes, everything I'm showing you here is working just like that. Our goal was to drive interoperability across different companies, standards, right? To enable decoupling standards, right, and to enable autonomy. And this probably goes a bit beyond what the original idea of these standards were, at least from the perspective of some people. Let me show you what's happening here. What you're seeing here is the agricultural use case. We have in the background, you see our little tractor. The video will get to show something interesting in a minute. So here you see a simulated run of this tractor. Here's the tractor that actually runs. And what we are doing here in this scenario is that all of our things and all of our services in this scenario, they expose Web of Things thing descriptions, like the tractor controller thing description, a waypoint service to navigate the tractor, an AI service for the camera of the tractor, a journaling service, I'll get to this, a human in the loop service for a mixed reality device that can be used to steer the tractor. All of this is shared using Web of Things thing descriptions. You can see all of our TDs if you go to this link, which I've also posted into the meeting minutes. I hope that you can follow on my screen. So here you see lots of thing descriptions that we have deployed as part of this project. And you're of course welcome to use these in other projects. We've also liaisoned with the DOMOS project, with the Domestic Operating Systems project, where we've found out that they are also using thing descriptions, but they used to treat them as confidential. We've convinced them that thing descriptions should not be confidential, and we've also shared across these two projects. So DOMOS was also a European project, but I don't think in the NGIoT spectrum. Then we expose things via a platform that we've created for this purpose. You also have the link to the platform down here. So you see this in the third link down here. This is what it then looks like. So here you see, for instance, for one of our robots, you see a thing description that is publicly accessible there. And then we use these descriptions to coordinate our things and our services. So specifically, we use a no-code development environment. I'll get to this, and then we can program software agents based on these thing descriptions to talk to our different objects, to the tractor, for instance. And then an operator can issue goals such as harvest field 5, and the rest runs autonomously. So the operator says harvest field 5. Our system system talks to the waypoint service to get the waypoints where the tractor should go. It talks to the tractor to make it move there. It brings together the AI service with the camera on the tractor to analyze pictures in order to ideally avoid deer. I think that this is not implemented, but this is laboratory state, and this is what we can do with this system. We have a twin of the system switching to the industrial deployment. We try to apply the same architecture to both deployments, and I think we succeeded with this. Specifically, the parts that I'm showing you are the same across both deployments. So here we have a little bit of a web interface where you configure what you want to have. I want to laser engrave, laser cut the text IntellIoT into one of these wooden plates. And now, again, everything here is described using a thing description. So again, the W3C standard, the robot controller, the engravers, the robot controller grabs this thing. It was told by a grab spot service, which also has a TD, where it should grab it. It puts it into this engraver, which you're seeing right now, and then the engraver starts engraving the text that has been put. So again, these are deployed via the same platform as per before, and again, they are programmed using a no-code development environment. And in this case, we program a manufacturing agent to achieve the goal. In this case, the goal is engrave the text IntellIoT, and you should see this in few seconds on this video. So this flips down, and now we can close this, right? We can close this, and all of this is done by software programs that use TDs to actuate these different things. So here we go for the engraving, and now I stop. Right, so now this starts engraving a text into it. The whole thing is a bit complex, which was the idea. The idea of this project was to test thing descriptions in a more complex setting, in a more dynamic setting as well. And the way that it works for us is I'm using the industrial use case as an example. We have a robot. That robot has a web API. We also have tiny things, tiny devices like sporadically powered photovoltaics, so little embedded systems, and we have this central platform that I was advertising before as hosting the TDs. So what happens is that these things advertise their TDs to this platform, their thing description to the platform. Then a no-code development environment gets the TDs from there, creates functional blocks that can be used by a person from these TDs. Then the person creates an agent program. The program is deployed. The agents are deployed. The agents run this platform. And then they talk to the different services given a user goal. So the user would say, please engrave this text, give this to the platform. Then there are agents there that want to achieve this goal and talk to the different services and devices to achieve the goal. And all of this is journaled in a distributed ledger. It's not particularly interesting. I think that this is a distributed ledger, but all of this is journaled over here. So all the interactions that are executed are journaled over there. Now, what I want to show you is 3 aspects and 2 half aspects. The first is the management of W3C WAT TDs, which I think is interesting in this context. Second, the no-code development. Third, the W3C WAT TD negotiation. In this TD negotiation, there might be some aspects for future work, and then I'll basically skip over the past, about 4 and 5, but you will have the slides, and then I'll introduce you to a new development standardization oriented group that we've created on the basis of this project. So first, what we are proposing in this project is that we manage what thing descriptions using a specific web infrastructure that we refer to as a hypermedia multi-agent system infrastructure. We support the creation of agents. In this case, these are software programs that run without human intervention for an extended amount of time. Please don't make me go into a definition of intelligent agent right now. And here we want to support the execution support these agents to use different computational artifacts. We want to support them to instantiate artifacts. Like if they discover a new robot, they can instantiate it in this workspace, in this infrastructure, and then they can use this. This is what I've said. The resulting full environment is represented using RDF. So this is in line with the standardization effort behind W3C WAT. And all of this is compatible with the search engine that we created a few years ago for the W3C bot. We propose that this infrastructure could be a blueprint for more complex systems that are based on W3C Web of Things thing descriptions, and that might include autonomous software programs as well. And here are the links to our different articles and to the environment that I was showing before. The second, I'm being fast, obviously, right? The second is that we wanted to look into end user programming. In our case, this refers the end user is a domain expert. So the end user in the agricultural domain would be an agricultural engineer. The end user in the industrial domain is an industrial engineer. And what we did was we created a block language based on Blockly, nothing fancy. But the interesting thing is that the functional blocks in here are generated from W3C TDs, and the bindings are resolved at runtime, right? So this would avoid hard coding URLs, for instance, at compile time. So if a service changes its interface at runtime, our agents adapt to use the new interface. So ideally, at least on the syntactical level, things should not break anymore with this. We've used this IDE to create agents based on W3C TD, and the way that this looks like is that on the top right you see one of our implementations. So we want to steer a tractor, and all of this steering is based on so-called W3C TD affordances. So we don't program in terms of the API, but we program in terms of the API's affordances. And then over here you see, this is from our laboratory. You see how this tractor bot, which is here, the little one, how this one is executing this program over here, and the larger robot, the pick and place robot, is also executing a program, an agent program that has also been based on Web of Things TDs. So this is nice. Then an interesting thing that came up during our discussion was that our partners, specifically Siemens, they desired to deploy things as late as possible. So they wanted to have lazy deployment of edge services for optimization of their industrial edge computers. They didn't want to burden these computers too much. So for this, we've been using the W3C TD templates in version 1, which are now called the thing models in version 1.1, for permitting late binding of edge orchestrated services. And what we do in our system is that we emit a thing model. So this is like a query to ask for a specific runtime bound device. This is emitted by an edge orchestrator. So the edge orchestrator says, I would like to use something that can pick and place, simplified slightly, and then we can already program using this thing model even without having a robot deployed. But at runtime, so I program against these thing models. But at runtime, this edge orchestrator goes to our infrastructure and runtime deploys a device that actually fulfills the thing model and that can be then used by the agents. So the proposal here is something, I discussed this with the W3C group already a few months ago, something like W3C TD negotiation. So possibly parameters of machine learning systems could be used to negotiate which specific TD I should use at runtime. Maybe also security parameters could be used for this negotiation process. And the core use case is what we got from Siemens, which was the optimization of the industrial edge. So late binding of thing descriptions. In the end, any non-functional parameter of a service could be used in this sense. So I publish only the thing model, and then at runtime I bind to it, depending on runtime parameters. The two smaller aspects that I had was journaling of agent artifact interactions. So basically what we did was we are using thing descriptions also as a template for journaling interactions. So if we can do this, then we can do auditing of a system, past execution. We can monitor the system. We can do root cause analysis. Probably we can possibly do payments based on this. So based on what actions have actually been executed. And finally, on the research arm of this, we've put W3C TDs in the context of affordance theory. You see the paper over here, and what I think is the most interesting thing here is that we might differentiate, we might advertise different TDs to different types of agents at runtime. So we might adapt to agent goals, or we might adapt to agent abilities. To make this a little bit concrete, if I have a robot like this one, and this robot can maybe pick something, But it could advise to agents that are whose cognitive architecture is based on PRS, is based on the procedural reasoning system. We could advertise the ability in this form. So this would refer to desires, for instance, which can be seen as a concept that is compatible with PRS. Alternatively, if we have an agent that is a planning agent, for instance, a strips planner, we can publish the same functionality, but in a way that can be consumed more easily for planning agents. In this case, you see that this agent requires things like preconditions, which are typical things that planners require. With this, I'm at the end. This over here is an overview of what we were doing. And finally, I want to advertise that we created a new W3C community group. This was based on a Dagström seminar that we conducted this February with all these people. The idea of the Dagström seminar was to get together traditionally fragmented communities, the Web of Things community, web architecture communities, autonomous agent, multi-agent systems community, also the semantic web community. So we have a few people from all these communities here. Dave is here in the middle. And then from this Dagström seminar, we create a new W3C community group on agents on the web. And this already has 75 participants. So it seems that there's at least interest in this idea of how could we create systems where software programs make more autonomous use of devices and services with published thing descriptions.
So thanks very much for that. Do you have any particular topics you think we should discuss as a group? And we can.
What popped up was this one. What popped up several times also with Ege Korkan from W3C was this thing, this TD negotiation idea. So
okay. So I don't want to spend a lot of time on that now, but if you could perhaps type in the points you'd like to raise under the section on open discussion, then we can come back to that later. Thank you.
Happily. Thank you, people.
So, Jens, are you ready?
Yeah, I guess it's my time now. So let me try this. So do you see?
They're on, right?
Well, yeah, there was. I mean, I don't know because there was a double presentation. I think there was Simon and myself.
Yeah, I said 15 minutes.
Yep, I would be less technical. Don't worry. Should I go now or a bit later?
So sorry, guys. Are you seeing my screen or should I?
I think it's Jerome, if I understand correctly.
Sorry, it's my fault. I misunderstood about the previous presentation. So it seems like Jerome wants to make a short presentation too. Is that correct?
Yep.
Okay, go for it.
I will share the entire screen. So. Do you see the screen?
Yes.
Okay, so that will be. I mean, Simon made a focus presentation on the Web of Things and the achievements with use case 3. So the industrial use cases. Here, I just wanted to also discuss a little bit the other use case and go into more high level of global standardization contributions from the IntellIoT use case. And I'm pretty sure I will not cover everything, so that would be just used as a topic for further discussions. So this is the other agriculture use case that was targeted in IntellIoT. So the system is a bit. The object is always the same. There is basically something. So there was the robotic arms for Simon, but it is now the tractor. He has a specific obstacle that he has to obtain. And what was important here is that the tractor can drive by himself, but if it discovers something that is not known, there's two options. One option is to request an external intervention, human operator, that will indirectly retrain the AI model that is supposed to understand what's the potential obstacle. And if it's not possible, before that, there was an alternative that is basically the first step towards something, the standardization particular, the 5G AI mentions as AI at the service, is basically the AI model failed to recognize the danger. Before asking external intervention, it will ask whether an updated AI or an AI specialized to that problem exists inside the private infrastructure here, and then return it before asking human operator. And then you see in the back something also important in IntellIoT. It's a private 5G architecture with private 5G edge / MEC, depending on who we were talking to, providing ultra low latency uplink and downlink. So that was basically the use case that was supposed to be addressed. I mean, that was to be addressed. The contributions to the standards, I will not cover W3C because that was already done by Simon. The in EURECOM perspective, what we contributed was in two forms. We contributed to the 5G architecture, so we were quite active toward 3GPP, and also this AI as a service architecture. So it was also parts of what Simon mentions, but also towards semantic and IoT. So part of the 3GPP, there was a few things that had to be done in the standardization when we do device-to-device. Everybody knows about the V2X technology for vehicles, but the problem is this is strictly, and I insist, strictly restricted to urban vehicular communication. If you want to do anything that is not urban vehicular communication, then you cannot access the current ITS, the ITX spectrum. You cannot, and it is valid for railways, it is valid for robotics, and it is also valid for agriculture. Don't ask me why. A tractor doesn't qualify for an urban vehicle. So at the end, we had to also look at how we can do device-to-device communication in unlicensed spectrum, because we have no idea where we could communicate with device-to-device between tractor and drones, or between tractors. That could happen when you are in this use case, but we don't have only one tractor. We have multiple tractors. We might even have people in the field. So it's important that the tractor can get information from the people in the field. So all of this required to also look a little bit at how we can do device-to-device in unlicensed spectrum. So the problem that we focus in terms of standardization is what happens if we do device-to-device that is not urban vehicular use case. The second was also the ultra reliable latency aspects. This is a buzzword, URLC, but concretely, this required to change the way what we see here is that we do a lot of URLC in uplink. And the problem is most of the 3GPP system is always based on downlink. So we basically have much more downlink capabilities than uplink. And the TDD, sorry to use a technical word, but the TDD patterns is usually optimized for downlink. And especially if we do uplink, then it's not urgent. And in our case, it must be URLC. So some activities had to be done at 3GPP to be able to propose new slot configurations and optimizations to maintain a URLC capabilities to be able to remotely control a tractor by a human operator. And what is hidden here is that the tractor has to send uplink the complete camera feeds to be able to be controlled by the human operator, but it also must send feeds for AI training at some point in time. Other activity, so that's actually further activity in 3GPP. Okay, the TDD pattern is something that we also looked at it. Another activity that we basically observed as a potential limitations is that in 3GPP there is basically two types of frequency bands: FR1, FR2. FR1 is below 6G. FR2 is above 6G, 6 gigahertz, not the generations gigahertz. But in terms of the numerology is how small a slot is in a cellular world. So the default one is 1 millisecond. So if you can, and that limits basically the minimum delay you can get. So you transmit one piece and a fragment of a packet in 1 millisecond, then you know that it's not comparable, and you will never reach really ultra low latency. You can go to much lower slot time, up to 125 microsecond, but that actually is usually reserved for FR2 for multiple reasons. But during the IntellIoT project, we proposed that we should probably, for physical reasons, the numerology 4 cannot be done in FR1, but FR3 we still believe it could be possible. And the reason why we looked into it and tried to at least make some preliminary tests is that this would be one way of providing ultra low latency in FR1 and not FR2. Why do we want to do FR1, so sub 6 gigahertz? Is because it's first significantly cheaper, and second is omnidirectional. You don't have to point the directions towards the tractor you're actually looking at, and that's actually something much in terms of operation much faster. And a last part that we also looked a little bit into 3GPP, even though that it is partially 3GPP and partially IoT, but it's the extension of the fact that we have inside inside the private 5G, we have to handle a lot of AI solutions. So we have to update communication, but based on the AI, but we also have to update use cases based on AI. And 3GPP has functions called NWDAF, network data analytic function, which actually in the updated versions becomes a data analytic. It's not more data analytic, but AI functions. So we basically started to develop what we call AI as a service, AI as a service architecture, and started to set the potential APIs that would be required for the private 5G systems to be able to seek AI models that they might not have. In terms of ETSI, we basically, it's considering the fact that the tractors are having a lot of sensors, tractors and cars have a lot of sensors that has to be transmitted uplink. We have to also optimize what needs to be transmitted and not transmitted. So that was one of the the contribution we did in ETSI, and we see as a very active strategy in ETSI, ETSI ITS, sorry, I should have said that, sensor perception, so basically sensors, but also the generic navigation strategies. So how we negotiate a navigation for a tractor. So these are two very active contributions, and one of the things we started to look at was that there is a misunderstanding and a potential challenge, at least in the ETSI ITS, when we compare platooning and something called maneuver coordination function. So maneuver coordination function is multiple object needs to coordinate to maneuver jointly. It is one thing. And we have another we have another types of use case, which is called platooning, which is also a specific case of maneuvers, except that one leader is maneuvering for everybody else. But the problem is these two approaches are not really compatible. There is a open questions at ETSI and beyond ETSI about what happens if you have a platoon that has to navigate to jointly to coordinate with other cars for joint maneuvers, for example. Beyond the platooning per se, maneuver coordination aspect is also something we looked into it. Now, concluding this presentation quickly, this was the thing we contributed during the IntellIoT. Still open or aspect that we would seek further discussions and see how we could further move over it. You heard Simon mentioning that W3C autonomous agent on the web is something, a very big achievements. It's really worth contributing towards it. But we also discovered another challenge when we looked into this AI as a service platform. We also have to look at potential AI semantic, because if we start having models, if we go to next generation IoT, it means that every nodes might actually generate an AI model, but we don't know how to name it. It's partially linked to the autonomous agent on the web, but it's also linked to semantics in the sense that how do we name a model such that it can be understood, it can be searched like you would search anything on Google. You search something and Google will understand what you are actually looking for, or making you proposals and you pick the first hit. So this is typically something that we saw that there is a lack of potential standardization. In ETSI, ETSI is standardizing, ETSI-ITS is standardizing things related to device-to-device communications. The problem is it is strictly limited so far to vehicular environments, no industrial environments. And the last part is there is also there is an elephant in the room that no one talks about, but it's huge, is that in ETSI at least, but we see that also in the tractor, we see it in tractor use case and in other use cases, we have something called the local dynamic map, which is basically the central database that is storing all the intelligence when data fusion is done between agents. And this, so far in ETSI, there is no way of synchronizing them. Everybody does what he wants to do. There are messages to exchange informations, but the way you are going to optimize what is done in which level of the agents, whether they are the edge agent, the MEC agent, the cloud agent, or even between agents, this is something that is widely unstudied. And 3GPP, one thing that we had a use case on TSN, but at the end we didn't address the TSN for 5G. So open interface was provided for, we provided a private 5G, but it was not TSN grade. And by looking at the 3GPP standardizations, there was actually, it was again something that was extremely challenging. First of all, the TSN is not only about providing the 7.9 or the 5.9 reliability. This is one thing that is, let's say, impossible to do anyways, but it is also providing the 5G network as a TSN bridge and all the underlying implication that it will make. And during the project, we also looked at the challenges that we need to do in open interface, and it is actually quite huge. There's plenty of there is ongoing standard in 3GPP, release 17, 18, but there are still things that actually are not available. We don't even know how we can actually do that. In particular, I just give one example, is how we can get the 5G timing access in a UE. Something that we want to get the 5G timing access to be able to compare with TSN timing. This is something that is not really specified. We still, still not sure how we can provide it in 5G. Another aspect is ProSe. So the device-to-device aspect, ProSe is a proximity service. So it's a service architecture for device-to-device. But when we started to integrate ProSe plus IoT services, we have a conflict of service. Who is creating the service? So if you have a service on top, and then you have a proximity service that is basically creating the service between two entities, you have this kind of service stack. And it is not really traceable because at the end, we don't know exactly who secures what, who enabled the service. And even though that the proximity service in 3GPP makes sense, as soon as we integrate that into an IoT architecture, we have conflicts. So this is something also at some point it needs to be harmonized. And generally speaking, just an open point across SDOs is security and privacy. In IntellIoT, there is a very strict, strong input towards DLTs, so decentralized ledger technologies, which and we had components in each of the use cases that had DLTs to certify and to secure the behaviors of the use cases, but the challenge we see now is that it's not fully clear how they are individually integrated. If I want to use DLTs in ETSI, how do I do that? No input. If I want to do DLTs integrated into 3GPP, that's something we also have to check. I mean, 3GPP usually says it's beyond our scope, but then where should we do that if we don't use security of 3GPP, and so on and so forth. So this is also something we found that we should look into it. Okay, that's it for my presentations. I hope that it was not too long, and open to questions or to further discussions.
I thank you, Jérôme. Just out of curiosity, this is Armir from TERMINET. The V2X or D2D in non-licensed spectrum, which frequency bands are you considering?
6G, above 6G. So basically you have the 5.9. Yeah, you have the 5.9, and above you have this new Wi-Fi / whatever. No one knows what they want to do there. But that would be one of the area. But generally speaking, at the end, it doesn't really matter where, and as long as it is not a millimeter wave. The idea is we want to generalize the fact that, I mean, this is a side note, but at the very beginning of the V2X, Qualcomm, and not only Qualcomm, Ericsson and also Huawei was basically saying that they want an exclusive use of the cellular V2X in the ITS band because they could not interfere with the ITS, with the other technology, the Wi-Fi system. But now that there is unlicensed bands, what was said to not be possible before now is a major source of research. So the idea
absolutely. But somebody should pick it up. There should be investment.
That's a well, you know, if you know how 3GPP operates, you need someone that has a use case and that is extremely motivated to make it happen. We are just merely academics, so when we have a use case, typically for IntellIoT, then we push. But compared to the big guys, we are just amateurs. We have two guys that are contributing to 3GPP. But usually the other stakeholders, when they come with families. So that's a joke, but you know, it's like they come with 10. And when they do something, then 3 months later, it's done. So it's clearly something important. At least for our perspective, we work on it, and we try.
I think we better move on now in the interests of time. So thanks very much for the presentation. And we can please, as I said to Simon, if you have some things you think we can usefully discuss together, please type them into the open session in the meeting notes. Thank you. Now, okay, I think it was it Jens next, right? Yes. Thank you.
Okay, so can you see my screen?
We can.
Okay, great. Yeah, so I guess we are a little bit low on time. This presentation, I guess, will be a little bit different compared to the previous because, yeah, we in VEDLIoT, we are not using W3C or ETSI or 3GPP. So this is, yeah, going to be a little bit different. That's why this is both an overview presentation of VEDLIoT itself as well as on the standardization activities. I have a summary slide in the end, which, yeah, lists the different standardization activities within VEDLIoT. So I will try to be quick, first presenting the overall ambition of VEDLIoT. VEDLIoT, yeah, in contrast to, for example, IntellIoT, is let's say not so much focused on the use cases. We have also plenty of work on the hardware side of things, meaning that we are developing a scalable, heterogeneous, and distributed hardware platform within the project, together with a focus on accelerators and tool chains. For sure, we have the use cases from industrial IoT, automotive, and smart home, which I also will be briefly present within these sessions, as well as the open core projects, which we let's say try to integrate, and I guess we succeeded with that. Try to integrate very closely to the main project. This is what we called a big picture of VEDLIoT. We see the hardware platforms below here, and this is also the first standardization activity that we have in VEDLIoT, really standardizing the different microserver formats, and I will come to the way we have done that within VEDLIoT in a minute. So to let's say do standardization on, let's say, quite a different level about compared to what was discussed before. So we are not having some let's say TDs or something like this. We are really working on standardizing microserver form factors, standardizing interfaces, standardizing really hardware kinds of things. Then we have the middleware layer, which introduces the different tools, and there we mainly contributed to lots of open source projects. This is formally not standardization, but if you contribute to, let's say, one of the bigger projects, which are, let's say, I would say, kind of quasi standards, because everyone is using those. like, I don't know, the RISC-V or something like this. I think that is also something that you might want to consider as a, let's say, standardization thing, or at least a quasi-standardization things. Then we have the applications here listed above, as well as aspects of requirements engineering, as well as security and safety, and especially in the requirements engineering section. We have some activity ongoing which might be worth to look into with respect to further activities on standardization activities, especially related to, for example, something like the EU AI Act or something like this. But first, let's say starting with the hardware platform to get you the basic idea. This is a slide that I'm showing for quite some time now, I guess from the beginning of the project. So the idea within VEDLIoT on a hardware level is to create this cognitive IoT platform, combining, let's say, all the heterogeneous technology which are out there, meaning the traditional x86 or ARM things, the RISC-V things, the accelerator things, FPGA things, and so on, to really create a platform which, on the one hand, covers all the different architectures. So you can think of this as really multiple dimensions, and on the other things, the full spectrum, really from embedded over the far edge, near edge towards the cloud, so that you can really scale these things, improving performance, maintainability, energy efficiency, and so on. The way we've tackled this, and I will go quickly over this, is we have created a set of different platforms that we are calling REX platforms, integrating those technologies in different flavors, let's say like the high performance microservers, the low power microservers, combined with let's say scalable and high performance communication infrastructure, because as you would all agree, communication is what in the end really matters when it comes to getting performance out of your compute nodes, so to say. And this is both within a server or between different nodes within a, let's say, compute continuum, if you want to say so. So what you see here is the platforms that we've developed more for the cloud side of things, because it's quite highly integrated, and you can have up to 144 of those small microservers in such a box. Then it scales down to the edge use cases, where we have developed what we call a T-Rex server. I'm going quickly over this here because it's not so relevant for standardization. What is relevant for standardization is that those microservers are basically using then common form factors. And we have done the same thing for the far edge for the far edge architectures, with what we call the MicroX AIoT server, which are supporting standards like SMARC or Jetson. All of them being, I mean, Jetson is a proprietary standard by NVIDIA, but SMARC is an open standard, not standardized by PICMIC, but by another standardization activity here inside of Germany. So this is the microserver overview. As you're saying, it's a zoo of different microservers using either proprietary, like for example the Jetson ones, or open, like for example the ComExpress or ComHPC microservice. And within VEDLIoT, we have then on the one hand looked at the performance at all of those accelerators or microservers, really running a quite huge benchmarking campaign, comparing the performance of the different nodes across each other for using, let's say, standard networks, for example, ResNet, EfficientNet, or in this case, YOLO v4. This is something which, is also one of the ideas for really looking into standard data sets or standard ways for doing, let's say, comparison of performance metrics or something like this, so that you have standard data sets, standard networks for doing benchmarking campaigns. Because it is, at least from our point of view, quite some effort to really compare things across different architectures, as we are doing in VEDLIoT, and to do this in a fair and open way. On the hardware side of things, as said, VEDLIoT was or has been active in the PICMIC consortium. This is an industrial-driven, large and open consortium, which has developed COM-HPC. It's final and released for quite some time now, and we have successfully released the 1.1 and the 1.2 specification. It's basically, as said, a specification of a computer on module or microserver form factor, and you have these different kinds of let's say mechanical definitions, of interface definitions. You have all those different kinds of modules, from the smaller ones to the bigger ones here down, so that that is something where we as a project contributed to, and did that together with companies like Intel or Congotech or Advantech, which are active in this field, really also selling products based on these standards. What else is going on? In VEDLIoT, we are also working on reconfigurable computing using FPGAs, and for example then the Xilinx DPU to basically have a large variety of reconfigurable architectures that we are evaluated in the same way as before, which I showed. And also the question here is then, what is the best way, or what is a standard way to compare against other things? I mean, for sure you can pick the benchmark data sets and so on, as we are doing, but that's one thing which I guess could be done in a more harmonized and let's say standardized way of let's say tackling the process. Same thing here for the co-design. It's not just that we are doing this for, let's say, one kind of let's say underlying IP core or hardware, as I just showed the Xilinx DPU, but we are also doing this really in a co-design session, optimizing across the full stack from the hardware, then really up to the application. Let's say playing with things like what is a better way? Would you have one engine per layer or multiple engines per layer? How are you dealing with distributing the layers across the different computer architectures, and so on? Now switching to something completely different, the security aspects. Within VEDLIoT, we have a focus on WebAssembly and integrated trusted execution environments within WebAssembly. We have developed for both the Trust Zone as well as the SGX. So Trust Zone is the ARM side of things, SGX is the Intel side of things. Ways to integrate these trusted execution environments within WebAssembly, and have contributed to open source projects in that area, which I'm not sure whether that's relevant for standardization, but that's at least something which I think is at least relevant when you look at standardization things, because those are things which are used I guess basically by almost everyone within the industry when it comes to trusted execution. Other things that we are also looking at is attestation, as well as a secure IoT gateway for let's say securing IoT connections towards the cloud. Then with respect to safety and robustness, we have work together with VEDLIoT from Mount Micro. That's a project partner. However, VEDLIoT is a yeah, let's say open source project which was not, let's say, established within VEDLIoT. It's already quite big and has grown for many years now to simulate basically yeah, machine learning accelerators, or basically multi-node environments. It has a particular focus on RISC-V as well. I'm not sure whether you're familiar with, for example, the Google CFUs. CFUs short for custom function units. The Google CFU playground, which, yeah, let's say in the background uses VEDLIoT as a basis for the things which are ongoing there. Then something which I see as a thing that might be worth discussing further on is we have done some work on the requirements engineering side of things and come up with a compositional architecture framework for design of AIoT systems, really covering all the different levels that you go through when you're designing such a system, from analytical to runtime, covering things like logical behavior, AI design, hardware, all these things to, for example, quality concerns or even ethical considerations, which can be helpful when you're dealing with things like the AI Act. There's no, so this is there. We have done some publication work on this, but I think it can be used, for example, for dealing with things like the EU AI Act, where you need to prove that you have, for example, no bias in your AI network or something like this. And yeah, currently we don't think that there is a common standardized, again, way to do such a thing. Within the use cases, I will just quickly go through this. We have the in the project, the automotive use case, which deals with collision detection and avoidance scenario in a distributed fashion. So we are distributing the tasks from the vehicle where it's normally done to the edge and even to the cloud. So the challenge here is really the distribution of work. We have a number of industrial IoT applications, for example, the drive condition classifications, which is basically a predictive maintenance use case, where we are dealing with things like low power and efficiency challenges. So we basically, even though it's attached to a very big motor, you are worried about the battery life of this unit because it's a retrofit device. And in the same domain, also in industrial IoT, we are working with the arc detection, where we are using, or where we are trying to detect electrical arcs in DC distribution systems, where also accuracy is a challenge, because both false positives as well as false negatives provide a challenge, because when you're basically having a false positive, you are switching your whole production line, your whole production plant off for basically no reason, which is a huge problem in terms of financial loss. And when you have a false negative, you're not detecting an arc which can cause a fire, which is also as you surely agree, a very big problem. So accuracy is really the main challenge here for this use case. And then we also have a smart home or smart mirror use case, where we are dealing with basically lots of compute intensive ML applications like face, object, gesture, speech recognition, and there we are dealing with data privacy as well as efficiency constraints, so that the whole thing does not consume too much power. Then, as said, we have tried, and we have successfully tried to integrate the open calls into the project, extending the use cases from various things like a driving school use case, where we are using AI to automate and let's say assist with driving exams. So you are having, for example, again, the regulatory constraints, or laser welding, where you're basically using AI to control the welding process in the localization, or for example, something like a pollen analysis for honey, where you are using a microscope that then automatically tests your honey or the different components of the honey in with respect to quality concerns, and again also, let's say marketing or selling the honey in the end. So that was, I was trying to be quick. That is then my short summary. With respect to standardization in VEDLIoT, I see a strong contribution from VEDLIoT, which is still ongoing, to the PICMIC standards COM-HPC as well as COM-Express. This is the hardware or microserver form factor. We have weekly meetings within this industrial driven or industrial dominated standardization bodies there. We have several open source contributions to large open source projects. There's a list on our homepage. Things like VEDLIoT and Canning, which are emulation and simulation or simulator environments for distributed IoT, including, for example, things like support for VEDLIoT. We are doing memory protection for RISC-V, also an open source contribution, as well as trusted execution environments for WebAssembly. As I mentioned, we have done this both for TrustZone as well as SGX, so the ARM and the Intel side of things. When you're asking for recommendation, I think this design frame or having a, let's say, commonly standardized and accepted design framework for IoT and AI, so something like we presented with this compositional architecture framework for AIoT, which can help to design systems that comply with regulatory constraints. Let's say, for example, given by the EU AI Act, which is discussed and is going to, I guess, be released within next year or the year after, as far as I know, is something that, we would, let's say, focus on, or we would advise to look at. And that's all from my side.
Thank you. So I think we were due a short break now. Theodoros, what do you think?
I think we can have, let's say, a short break for 10 minutes. Let's get back at 14:20, sorry. Okay.
Okay, thank you.
Okay. Thanks a lot. So, are we all here? Armir, are you here?
Yes, I am.
Okay. Can you start?
Just a moment. Can you see the sharing?
Not yet.
Slides?
No.
Try again. What about now?
No.
Okay. Because I have an external monitor, but let me just bundle everything in one. I don't know, I try to share, but then it interacts it, but then it disappears immediately. I don't know why.
Can you try one more?
Yeah.
Otherwise, please, can you send me the presentation with a mail in order to share it? Maybe it's easier.
That I can do, but I mean, I see that the sharing starting to take place, but then it unshares.
Okay.
I don't know why. This is strange. This has never happened. Okay, in the meantime, I will send you the slides. Also.
Okay, send me and I will share it.
Just as an interruption, after the meeting, I will send an email, just if possible, asking everybody to send their slides to me, because that will help with cleaning up the minutes. And then let me know if you think we can share the slides publicly. Thank you.
Down, Theodoros. In the meantime, I will stick to trying. No. Same situation presents again.
Okay.
It shares and unshares.
Okay, I don't know why, but
probably because I'm using this, I mean, a relatively recent progressive app that Teams has for Linux distributions.
Maybe, I don't know.
I don't know.
Let me check. Okay, just a minute. Let me open this file. Okay. Okay, let me share this now. Share. No. Okay, let me check this. Okay.
Yes, we can see it.
Okay, perfect.
You can see that. I cannot see anything, but I know the slides because I have them in front of me.
Okay. Not even now, Armir?
No. But
okay, if you have the slides in front of you, okay, I will proceed to the second.
I have my slides and I have the numbering also, so apologies to all, but this is an example of heterogeneity unsolved. I am Armir Bujari, professor from the University of Bologna, associate professor and researcher in the, let's say, broad field of distributed systems. Now, in slide 3, there is a, let's say, a highlight of the TERMINET consortium, different industries involved, universities and research centers. And there is a bulk of SMEs, some of which are use case proponents. And as you will have the possibility to see and understand, there is a lot of heterogeneity involved within the use cases that TERMINET addresses. Now, in slide 5, there is a bit of a motivation which say has a lot of commonalities with what was already discussed by the other, let's say, projects. So one of the main, let's say, motivations and pillars is that cloud computing per se is not able to support a real-time, let's say, application or next generation applications, which are driving also most of the innovation today. At the same time, we are in need for a new cost-effective approach. So push the computation towards the data sources in order to enable low latency services, but also via, let's say, new emerging learning paradigms, we can achieve what is called the privacy by architecture and by design, let's say, approach. So we also need to enhance the IoT world to address the heterogeneity problem. Heterogeneity, by the way, which spans across the layers and concerns data, concerns platforms, concerns communication protocols, with a final goal to embed intelligence nearly everywhere. Now, in the next slide, there are some challenges, but I won't burden you with these because these are quite well known. And in the next one, we have, let's say, the running objectives that TERMINET as a consortium has pursued along this roadmap. So being the objective 1, and we'll discuss some bits related to this objective by discussing the reference architecture we have conceived and come up with, which is to enable this flexible, open, and decentralized, distributed and decentralized next generation IoT reference architecture. There is a second objective, which is related to network programmability via the use of software-defined networks. Okay. A third objective, which is related to, let's say, decentralized or distributed, or both of them together, AI technologies. Everything should be glued together via well-established and state-of-the-art and beyond SOTA, and there are some elements within the project of this sort, by security, let's say, a layer. Security meant as remote attestation techniques, lightweight, let's say, encryption mechanisms, and another element, which is that of the use of distributed ledger technologies as a logging fabric. Now, all these in order to introduce and have the right methodologies in place in order to introduce new intelligent IoT devices within, let's say, this architecture. Moving along, let's say we have some pillars which were already highlighted, like the use of softwareization technology like SDN and network function virtualization, rather than network function virtualization, which is, let's say, not the actual scope of TERMINET, but conceiving mechanisms and algorithms. Think of end-to-end slicing algorithms, which are or can be in the near future 5G ready or 6G ready and easily deployable. Federated learning, decentralized and distributed learning, which is, let's say, the emphasis or at the core of TERMINET, by distributing intelligence and inference and the actual learning to the edges of the network. Then the introduction and methodologies to introduce, let's say, new IoT devices via the use of digital twin. And within this topic, as University of Bologna, we are actively involved within the topic. Then, as I said, glue everything together via a vertical, let's say, security layer, which protects all the layers of the reference infrastructure, not only concerning the data, but also the computation part. In the next slide, being slide 10, so there is this layered architecture, layered conceptual architecture, let's say, conceived within TERMINET, and we'll talk about an instantiation of it. Starting from the bottom part, you have all the IoT devices which directly connect to the intelligence above, or they are mediated by proxy agents or digital twins. The data are sourced from the bottom layer, and it can flow from the bottom layer to the applications or the edge in a secure fashion, so data being encrypted. Now, all these layers are protected via mechanisms present or logically placed in this, let's say, logically centralized security layer. And in here reside mechanisms like attestation, trusted execution environment, blockchain technology, wherever it makes sense for logging and traceability of events that occur during the various exchanges, but also the computation itself. Moving on into the next slide, there is, let's say, a sort of operational view of what occurs. Now, a lot of research elements have been conducted in the access domain. So we have I2CAD as a partner, which has conducted some research evolving the recursive internetwork architecture by introducing support for wireless technologies, the way the devices are paired with the access network. Then we have the edge domain, and we consider different types of edges. Some of the technologies were already mentioned in the presentation before by the very efficient deep learning project. So we manage in a seamless way via lightweight abstraction devices like GPUs and specialized ones like FPGA, and they can be subjected to orchestration, or let's say state-of-the-art orchestration technologies such as Kubernetes. Then on the far right, we have the so-called core domain, which basically is the current cloud. Now, we are able, via orchestration and the resource, or let's say more broadly, resource management techniques, to move the computation across the spectrum of resources. Also, we have tailored mechanisms and algorithms so as to slice, so provide a slice meant as a set of compute and radio resources dedicated to serve a specific vertical. So TERMINET, let's say in a holistic way, aims to introduce or facilitate the introduction of intelligence, distributed intelligence. And the way it does so is by using some building blocks like softwareization, solving the heterogeneity problem, and management of devices in a uniform way by using state-of-the-art building blocks and adding whenever it is necessary. What we have in the upper part is, so basically the verticals or the use case proponents, including in here even the open call stakeholders, which were onboarded recently and have ended, let's say, their deployment voucher, could access in a uniform way this continuum via a set of dashboards, and then to them every operational aspect is transparent. Everything is managed by the TERMINET platform. In the next slide, we show, this is a brief overview of a series of use cases. And in here, one can assess a bit the heterogeneity and different demands that each use case has. Starting from use case 1, we have the user-centric devices in smart farming. This is a broad use case, and we have identified different scenarios like monitoring crops, monitoring livestock via different IoT technologies. And we would like also to provide the farmer with additional means so as to smooth operations in the field. Additional means, I mean smarter IoT devices such as smart glasses, so they can consult everything while on the field via these smart glasses. In use case 1, there is also employment of federated learning, let's say, from a distributed systems perspective. This is a distributed federated learning approach. And I do this differentiation because we have another use case which uses a distributed and decentralized federated learning approach, like in use case 2. So in use case 2 deals with pathways of personalized healthcare. So this is a use case proposed by iSprint, an SME within the project, and the Gemelli Hospital in Rome. They want to shorten, let's say, the time to treatment for their patients. And by the way, these are very sensible data because the patients are oncological patients. So in here, we want to realize use case whereby different hospitals or different entities possessing this sort of data, which are very sensitive, can, in a decentralized, distributed, and secure manner, share the models and not the raw data of what they learned. So to use networking effects to boost the model accuracy. There is another use case related to smart, sustainable, and efficient buildings. The use case proponent being CERT, another TERMINET consortium member. So this is a smart building, an instrumented building with various sensors embedded. And there are different identified scenarios. The main one, most interesting one, being that of lowering energy consumption via the use of predictive artificial intelligence. Now, this use case also tries to broaden its applicability and, let's say, look beyond the smart house and build an ecosystem of smart houses, what is called a smart community. with some data sharing involved among buildings per se. There is another use case 4, talking about prediction and forecasting for optimizing supply chain in dairy products. This could be valorized as a data space use case. So we have a supply chain and data sharing involved at different steps of the supply chain, and we want to adopt some predictive analytics so as to smoothen operations and reduce resource wastage. Use case 5, it deals with the use of virtual reality technology for medical training purposes, and in here some intelligence is used. It has 2 flavors, one predicting the variations in latency so as to have some proactive behavior and preserve the quality of experience within the session itself. And there is a second aspect to it where let's say federated learning is employed in this case, thinking of different stakeholders utilizing this technology so as to perform some gesture recognition within the session itself. And there is the 6th use case in which it relates with the industrial IoT domain and predictive analytics, similar to use case 1. In here, we want to embed intelligence in IoT devices so as to smoothen operations in the field. In here, we talk about smart grids, which are, let's say, big infrastructures. And so in order to pinpoint a switch or a router or a component within a switch or a router in this large infrastructure via the aid of IoT technology, this is paramount for the use case proponents, in this case being Ericsson and actually PPC and Ericsson. In the next slide, so slide 15, now, and different partners have different backgrounds, which are of course complementary, as we would not be in the same consortia. We have identified, actually we started an exercise bottom up, and we identified several, let's say, standards developing organizations, which we actively participate or we would like to pursue because we thought the technology conceived within the project might be relevant to that SDO. So this is just an enumeration, and there are plenty of them. Now, in the following slides, this is some ongoing efforts by the different consortium partners. So we have distributed the effort. Everybody works within its field of expertise. So in use case 1, what we did after the project kickstart, after the activities, we had a good grasp on the activities. So we started to identify relevant SDOs or relevant standardization groups where the conducted research might be exposed or might be of interest. So for use case 1, these are some of the potential standards, and we are actually pursuing via some other consortia stated in the right the effort within the standard organization bodies or actual standard mentioned on the left. Similar argument also for use case 2. Now, in here, this was a bit tricky, but I'd like to make a general argument. So different standardization bodies, or let's say those related to the telco world, to the industrial community, they generally neglect the data aspect or the data fidelity aspect. So data is something that is outside their scope, but with the emergence of 6G, which is still yet to come, it appears they are revisiting a bit the strategy, and they would like to include also considerations on the data, or at least methodologies and processes used to extract the data and make use of the data. As a consortia, we pushed a lot on this front, as you'll see in the last two slides, but this was to say that data is of paramount importance, and considering learning being one of the pillars, or enabling efficient and decentralized learning is one of the pillars of TERMINET, we have pursued different organizations of this front. Now, related to use case 3, a similar schema. So we have identified some standards, and partially on some of these as Unibo, and personally we participate in the meetings, and we have pushed for some elements conceived and designed within TERMINET. A similar argument also for use case 4, use case 5, and a use case 6. Use case 6, as I said, we have several industrial partners which are involved, and they are actually pursuing these synergies with the standardization bodies. They are already involved. On slide 22, so after having identified all these bodies of research, which partners were already, let's say, following their proceedings and were already pursuing, we identified also some other building blocks within which we could, let's say, provide a contribution. So related to the digital twin topic and different aspects of digital twins, we are actually involved, heavily involved in the Digital Twin Consortia by OMG and the Industrial Internet Consortium. And we are coming up with a white paper on what digital twinning and its evolutions should be in the, let's say, in the 6G perspective. Related to orchestration, there is a partner which is actively involved in the orchestration, but I'd say a network of automation and softwareization within ETSI, and TERMINET makes use of different container interfaces, CNIs, which have been conceived and are being employed within TERMINET use cases, especially in the Industry 4.0 use cases, like use case 6, where a low latency and efficient management and multiplexing of resources is paramount. There is another block where, and we have a representative partner in here, NEC, Felix, which includes the security contributions related to remote attestation and trusted execution environments. In the next slide, so this is, let's say, a sort of instantiation of those 3 pillars. So basically, in the first aspect related to digital twinning, so we have worked within the Industrial Internet Consortium some partners from the Industrial Internet Consortium and have written actually an RFC entitled A Framework for Cost-Enabled Semantic Routing in Industrial Networks. So the value proposition of using a lightweight semantics to evolve, to introduce, let's say, involved operational mechanisms in Industry 5.0 kind of networks, making use of both level 2 and level 3 technologies. Also, there has been quite some contributions from another subset of partners related to porting ML algorithms to FPGA-like devices and managing FPGA devices via container orchestration frameworks such as Kubernetes. Some, let's say, open source contributions also from I2CAT related to the access layer and the use of ARENA technology when the communication is via wireless medium. We are trying to, let's say, push for some open standard related to federated machine learning and specifically to the decentralized and distributed machine learning, which makes use of the multi-party computation, secure computation, and blockchain technology. So methodologies on how to glue and orchestrate these components together, so to enact a learning process. Now, this is a patent from NEC related to a security component, so a component located at the security layer, which does behavior analysis of infrastructure and software components. And of course, this is another, let's say, contribution, a prototype device, which is a sort of a SCADA device for use in smart grid industrial networks by Schneider, which was conceived and built within the scope of TERMINET so as to enable predictive maintenance tasks, but also allow the possibility to execute some lightweight and rudimentary logic on board the device. In the next slide, now, these are, let's say, contributions of TERMINET, open source contributions to existing frameworks. Now, one of these being on the bottom side, so is this CNI allowing to best serve, let's say, latency critical flows. So whenever you have a deterministic type of network, let's say time-sensitive networking, and an application within a host or multiple applications within a host which have conflicting quality of service requirements, via the specialized CNI, you can protect time-sensitive flows while serving and not penalizing best effort flows. So this is an open source project. We are currently, let's say, collaborating with Siemens on this front, and there is an extension of this CNI making use of a meta CNI. So this is a Kubernetes-centric contribution. We have on the upper part contributions and synergies with the ETSI Teraflow SDN. So these are, let's say, efforts that are being carried on by UPTech, which is a consortium partner. Also, there are some open source, let's say, contributions coming from TERMINET, like the UAV, let's say, swarm orchestrator, which is a 5G, or if one wants to push it further, 6G ready function that can be integrated within the SBA. On the next set of slides, so you see an enumeration of different, I'd say, a lot of research articles, and this list is not, let's say, exhaustive, that the consortium has produced, and concluding with a set of data sets which have been released and published and can be openly consulted, related to use case 1, for example, the Sherry-3 disease detection data set. We have published another one, actually main contributions coming from the PI group from University of Western Macedonia. So this one relates to the Peach-3 disease detection data set. There is an intrusion detection data set which has been published. So these are real data, in some cases anonymized, so as not to divulge any sensitive information from the context they've been extracted from. And we have also a synthetic data set which has been properly anonymized, and this data set has been sourced from the use case 2 proponents. Recall, very sensitive data which can be readily used by anyone. So with this, I conclude, let's say, my brief holistic overview of what TERMINET is, what our effort on the standardization front have and currently are. And if there are any questions, gladly, I will answer to the best of my ability, and apologies for the sharing part, but what can you do? It's Microsoft.
Dave, you're muted.
Cannot hear you, David.
Perhaps in the interest of time, we should take the questions to the open session. So if you have some topics
Yes.
arising, let's please add them into the notes.
Absolutely. I will be with you for another 15 minutes. Afterwards, I need to go to a lecture series.
Okay. Well, in that
but
case,
Anna is from TERMINET here. Yeah.
Okay. Okay. If there are no specific questions right now, perhaps we can move on to the final presentation.
Okay. This is Alex Fornes. Let me try to share the screen and see if I'm more successful than my previous colleagues. 1 second.
That worked.
It worked?
Yes.
Fine. Perfectly. So my name is Alex Fornes. I'm a postdoc researcher from the University Polytechnic of Valencia, and I will structure the talk in 2 parts. Similarly to the previous one, I will start with an overview of the project, and then my colleague Zbigniew will continue with aspects more related to our efforts in standardization. So these are the partners of the project. There is a group of universities, research centers, SMEs, and main companies that are working together in this effort. So, giving a context of the project, the main objective of the project was to develop a reference architecture for next generation IoT. Our approach was to do it in a multidimensional fashion, in which we have a set of horizontal planes that interact with each other. The data that is gathered and preprocessed in the device and edge layer is transported in the network one, and then processed in the data management plane, and finally consumed by the applications and services plane. These layers are cutted by the verticals, which represent inherent properties of the system or properties that are cross-cutting to the different horizontal planes, meaning that they are present in different planes and so on. So as part of the effort, we envisioned this architecture, which has a set of different views: functional view, node view, development view, deployment view, data view, a set of additional considerations that should be taken care when designing and implementing a next generation IoT system. And we have taken effort from previous projects, previous IoT architectures, and also the standards from the ISO IEC IEEE 4210 in order to envision it. And apart from this effort, the next part of the project was to actually implement or realize this architecture. We have developed or implemented a total of 41 enablers, different enablers from the planes and the verticals for the project. In some cases, we needed to devote effort in order to develop them almost from scratch or with very basic solutions. In other cases, if they were more mature, we adapted them to the architecture. So let's go very briefly about different stuff that we have developed. First of all, we have developed our own gateway and edge node, our Gwen, which is a prototype, hardware prototype that we designed as the main gateway for the project. We have developed it considering a set of the typical interfaces that can be used in IoT systems. In some cases, these interfaces can be expanded or added with the expansion modules that it has. Has been built using Yocto and including the different baseline technology that we designed for the nodes of assist-iot, and it can be tailored to any needs that a specific use case needs. And then apologies because of the lot of words and so on, but I wanted to summarize our effort in the different enablers that we have integrated. One of the main efforts that we started a few years ago was about the orchestrator, the service orchestrator, which controls the life cycle of the different enablers that we may have of the different planes and verticals and so on. With this orchestrator, the user can deploy a specific enabler in a part of the computing continuum, or it can let the system decide based on a set of policies and AI. Of course, it also adds some security rules related to networking, so only exposed interfaces can be accessed and internal components are not exposed. And also the possibility of managing groups of nodes, meaning that if we want to deploy a specific asset in one cluster or edge node, whatever, we don't have to be going one by one, but we can do it like all together. Different standards have been considered for this: ETSI-NFB, ETSI-MANO, ETSI-ENI. In any case, this is an aspect, the orchestration, that it's very well known, that it's evolving very much in these last years and will keep evolving, and it has a lot of room for evolving in standardization. We have also worked in other different aspects of the network, like in SD-WAN technology, in SDN, in VPNs, etc. We have adapted some existing solutions, and we have developed our own enablers, for instance, to create and apply policies from SDN to optimize traffic. We have developed also a set of APIs in order to interact with them with other parts from application levels and so on. So this is part of the effort that we have done in the network level. Then the technical advancements that we have implemented in the data management plane, we have implemented our semantic suite, evolving the efforts of previous IoT projects like IntellIoT. In this case, we have developed our semantic suite, basically aiming at being able to transfer from whatever format we have for the data, and whatever protocol, meaning Kafka, MQTT, API, in streaming, whatever, have the ability to annotate the data, to translate from different ontologies, and so on. Also, we have developed our own management of data for the enablers. We have developed what we called long-term storage enabler, which basically it serves as a backup for data for the rest of enablers of the project and also for the use cases. It exposes an API to integrate whatever post or get any kind of SQL or no SQL data. And also we have integrated our own MQTT solution, extended it using an API to have the ability of integrated filters and rules inherently in the different breaches of the system. Regarding the applications and services, we have the main platform on the project is based on an enabler called the Tactile Dashboard, in which we integrate all the application management dashboard that we have for the project. For instance, we have custom dashboards for clusters and management of enablers. We have custom dashboard from the Federated Learning Suite, the Semantic Suite, the Cybersecurity Suite, etc. We have integrated existing dashboards like metrics and KPI from Grafana and Kibana solutions, and we have also developed our own specific interfaces. So all the different interfaces can be accessed from the same dashboard, depending, of course, of the role of the users. Also, we have other ways to interact with the platform. We have an open API in order to access to the different APIs that are to be exposed to the outside. For instance, for the open callers, we use the open API as the main mechanism to integrate them. We also have solutions related to mixed reality, in which we have integrated proprietary device, in this case, a HoloLens device with the platform. We have also do it with other vendors. We have also our own enabler to, we call it the video augmentation enabler, which allows to having streams in which we identify objects that have with a pre-trained models and so on. Then moving to other aspects that we have researched and implemented, we have the Federated Learning Suite as well. Here we based our implementations in the Flower framework. We feel that here it's also a field in which there is a lot of room from standards because we felt that it was a little bit lack in this field. And also regarding DLT, we have different features implemented with different DLT solutions for logging, for data verification. Also, as part of the Federated Learning Suite, we have a ledger that is in charge of managing the model of trust of the different nodes that are part of the Federated Learning Suite. And yeah, basically these are, along with the cybersecurity aspects, the places in which we have devoted more effort in this project. Regarding security, we have implemented our own authorization enabler, trying to or making it like in a federated fashion, especially for machine-to-machine interactions. We have also combined centralized with local security policies, etc., and we have tested them in all the pilots. So in order to implement all the enablers, we followed our own DevSecOps methodology for the project, meaning that we integrated security in the different phases of the DevOps operations. We packaged almost all our enablers in a technology called Helm of Kubernetes. However, Helm is usually thought for packaging a specific container or for instance, a component make as a container. In our case, enablers can be realized as a set of components, meaning that can be realized as a set of containers or WASM, whatever. And we extended the chart generator provided by Helm with the needs of next generation IoT systems. There are some few cases in which we weren't able to do that, especially in those cases in which virtualization wasn't made a lot of sense. For instance, with HoloLens, we weren't able to integrate our mixed reality solutions as containers in the classes because they didn't accept it. But apart from a few exceptions, more or less all the rest of enablers were able to be encapsulated as Helm charts. All the code that we have produced, almost all the code, it's in GitHub or it's being moved to GitHub. Our Docker images in Docker Hub and our Helm charts in Artifact Hub. I said almost all the code because we have some specific teams in which for internal policies they cannot put their code in open source, but this is just one case, I think. But the rest of our code is being published to GitHub. And also when we are working with a specific, let's say, big solutions like, for instance, OSM for the orchestration part, we are directly contributed to the main source, not just in our repositories. Regarding to the pilots, because then my colleague Zbigniew probably will talk about them, the different solutions are being tested or have been tested in different environments. We have three main pilots. We have the port automation pilot, which is led by Terminal Link, CMA, CGM, and it's executed in the Malta Freeport, in which the main business scenarios that we consider are the management of assets, which with assets we mean, for instance, cranes or tractors, etc., meaning machinery that moves containers. Also automated assets cooperation, meaning some specific communication and use of signals from LiDAR, etc., in order to that, for instance, one crane can take the container from a tractor without the need of a manual operation. And also a third business scenario that we have here is the remote control of cranes with augmented reality. Instead of having an operator going to a crane on top of it and moving it, we have been able to put enablers in order to improve the reliability of connections from the augmented reality rooms. The second pilot that we have is a construction site, which was executed in Poland, and it's in green basically because since the construction was finishing, we have to speed up the trials and so on, and it finished earlier than the rest of the pilots. Regarding the business scenarios here, we had scenarios of occupational safety, meaning that we used different kinds of sensor data in order to managing workers' health, having geofencing in real time, access control, etc. Another business scenario that we have was the fall arrest detection. We implemented our own device for detecting a specific fall from, let's say, from a height in which an operator is working, and the system had to take care very quickly in order to try to minimize the risk of this accident. And the last business scenario that we have on the construction side was the safe navigation and with the support of mixed reality glasses. Last but not least, we have the automotive pilot, in which the idea is to monitor the capabilities of fleets in very large scale. For instance, with the first business scenario, we have the emission verification and diagnostics, with the idea that if we have a very large fleet of cars, let's say 100,000, and each of them having our edge nodes there, having the capability of managing all this data and also to diagnose and act at a specific car level. And the second business scenario that we have is a separated one. It's about exterior condition of cars, making use of AI, or rather federated learning, in which the idea here is to have the possibility of detect, let's say, scratches or some issues in the car's surface, making use of computer vision, and have the ability of making it in a way that if the company has a way to ensure that anyone has tampered these images, or the user, sorry, making use of DLT verification solutions. So overall, these are the business scenarios that we considered for testing the different enablers. Of course, we didn't want to test all the different 40 enablers in all the pilots. We selected a set of them. Let's say we have a baseline for the platform composed by 10 enablers, the essential ones, and then for each specific pilot, we selected some of the rest in order to complement and execute the business scenarios. So with this, I think I can pass the floor to Zbigniew to continue with the standardization efforts, and then we can answer questions.
Okay. Thanks, Alex. Do you see my screen?
Yes, yes, I can.
Yeah.
Okay, just to be sure. So I'm Zbigniew Kopertowski from Orange Poland, exactly from Orange Innovation Poland departments. So I'm in the assist-iot project. I'm leader of the standardization task. So we are, as I see, we are just behind the schedule already. So I will try to be brief and show our activities, standardization activities that we have in the project. We, as you know, there is a lot of SDOs or different standardization initiatives. So we choose some of them there when we have active participation. So the partners are members of these standardization organizations. So we choose ITU, HCI, IEEE, and also we are part of the IoTI initiative, where we are quite active in standardization working group. And also we have BDVA and ESCO ENISA, where our partner in cybersecurity area is as active member. So for the standardization activities, we used all, let me say, assets that partners provide to the project. And of course, as Alex said, we have many different technical subjects in the project. There is over 40 enablers in different technical areas. So we have a quite large, broad area for the standardization, also for the standardization activities. As you see on this table, we can, in different organizations, we have, of course, different groups, subjects, etc. So for us, we choose where we were most actively working. So in HCI, as you see, in ITUT and IoTI, we already contributed, make some contribution, but also we have active participation in other work groups, study groups, or initiatives. So we are also following some of them, not to contribute, but to see what are the status of the standards in the specific technical areas. So what we choose is for the technical domains, for the standardization activities, as we have in the project, the main, also one of the main tasks is the architecture. So we are working in IoT architecture, in data management. It is the second where we working in the data spaces, interoperability. And also related, as Alex mentioned, we have a pilot use cases. So there are also contribution that we made regarding related to the specific pilots. I will show you in the next slide. But of course, also we have the technical domains, including edge cloud computing. We are working in the networking subjects like 5G, SDN. As Alex said, we have IoT gateway, so it was developed the hardware, where are also many standards to use or even to compliant. Also in cybersecurity, DLT and AI. So we have I've also subject federated learning. I will go quickly about this, but I will show you what are our exemplary contributions in the, as I said, in relation to the use cases. We have a HCI contribution to the technical report, where the use cases for cross-domain data usability. for IoT devices. So 3 use cases were there included and analyzed. It is just a group for the cross-domain usability of IoT devices from humans and machines. So it is also AI aspects there and human interfaces. And the second could also be related to the use cases is example where in the IoT where we have a pilot tool with smart construction site services. We have a different, let me say, services like for safety of workers. So there we can also contribute in the architecture, in the requirements and functional architecture. And in the edge computing and networking part, we are actively contribute to IoTi reports, white papers for the edge computing impact on beyond 5G and computing continuum requirements for IoT edge computing. And then in the data and security, also in IoTi about the data spaces and interoperability. And in security, in the ESCO, there was the technical paper on different subjects related to the security in IoT. For, as you see, in many, anyway, as you see, in many different technical subjects, there is a lot of room, a lot of gaps. I think that there is no standards or there is some need of the standard. But for our interest is the main areas to contribute is in area of interoperability of IoT services. Everything what is related to the architectures and also security privacy area. For example, at the end, I want to show you, for example, what IToT study group 20 is working. They have several questions. Most of the questions are very relevant to our subject that we are touching in the project, probably also in your project. So here we try at least to contribute to 1 or 2 questions where this contribution will be later included, or it is a base for the future recommendation, because as you know, working on the recommendation is the long-term work, so it is perspective 2-3 years also. So also in ITU they work right now on the perspective on the next 2 years to have a new recommendation to issue. So that's the quick and brief my information which what are the activities in our project. So thank you for the attention.
Thank you. So I guess now we switch to open discussion. I'm trying to figure out, which are the topics which are the most important to us as a whole. So I was busy taking notes, but Theodoros, do you have any suggestions for how we should start?
Hi, Dave. I don't know how you can start. Maybe we can check the topics that we written. I don't know how else we can proceed. Do you want to go a quick round among all the speakers to see if they have something else to add? I don't know.
That might be a good idea. Okay. So Simon has already copied some points down. Do you want to say anything else, Simon?
Hi, can you please repeat? I missed you.
Sorry, I was saying we were going to go round the speakers asking if for topics they think we should.
I don't see Simon is here.
Okay,
Dave. Okay.
What about Jerome?
I think Jerome is here.
Yes, he is. is muted.
Yeah, I'm still here.
So do you have any particular topics you would like us to discuss as a group or take forward as recommendations?
Well, I mean, I think what would be interesting just to make this, because all presentation were very interesting on the achievements of the different project. That's something that is always interesting to follow. But now the question would be, I mean, the topic was to try to see what would be the general focus on where we should emphasize standardization, or when we could have some requirement in standardization. So I don't know exactly how we can maximize chances that we get something concrete out of it. Typically, by all the different SDOs, trying to have a document saying, okay, we have like 5-6 SDOs, and which are the different identified objectives that either have been contributed, but to some point is probably not where we contributed, but where we think there's still things to be done. Because individually, the thing I experience, it's particularly in 3GPP, but this is very something particular, but it happens in different SDOs. We go on separate ways, and we have no chance, because it requires to if we look at the way 3GPP operates, they operate in wolf pack. So basically, they are groups, and they push for something. They agree on one objective, and they push together, splitting the different. I mean, getting, of course, it's industry, so automatically they have the resources. We are European projects, so that's the funds would be something different. But it's something that's if we go individually, it's always difficult. We can always push a little bit, and it is very nice, but there is no. It's having a coherent document saying what has been done or what needs to be done, I think would be very beneficial.
So in respect to that, what about the kind of alliances we have, like AOTI, and the Edge Cloud, EU Edge Cloud, EU IoT? So I never remember that one. And maybe opportunities to further discussions, like at conferences like IoT Week.
Yeah, I mean, having these initiatives like AOTI and others, I think that they all make sense. But again, this is kind of a proxy. The point, my perspective would be, okay, if we look at for what my colleague from SunGallen presented, it's not going through IoTI. The important is to be in W3C. We need to be there. If there are people in different projects that says, okay, intelligent web agents, well, this is important, because at the end, project A, B, and D, they work on web. Then let's have some kind of a group that is contributing in a coherent way to W3C on the web agents. Because the more coherent and the more people are there, the faster the changes are done. If we go through AOTI, it's always good, but I would say the other way around. We go first through W3C, and then we go up to AOTI to say, okay, this is what we've done. I fear that if you go through first this kind of proxies, again, the energy is dissolved. And again, I'm not criticizing this AOTI and NGIoT and others. It's just fact that we have limited amount of time of that we can contribute. And any time that is going to making a presentation to AOTI or a white paper for AOTI, it's something we don't have time to go for concrete standardization. That's basically my current perspective.
I mean, one of the challenges for direct contributions to STOs is the time it takes. Participation, it can involve a lot of time, all the meetings and teleconferences and so on. So this is one of the reasons. Go on.
Yeah, stakeholders are. I mean, it really depends, because if there is the first part is to identify who wants to be something to be done, and then this can be done quickly if there's a strong push. If you look at 3GPP, I mean, 3GPP, the industry partners, they come in 3 months done. The first month they identify what they need to do. 3 months later, results are done. 6 months later, the system is standardized. It's done. of course, it's high-level standardization, but it's done. But they have the push, they have the power. They contribute in a wolf pack. They really go into one leader, 5, 6, 10 people doing the results, and then it's done. So what I see in all the standardization activities in the European project is that it's diluted. We all do some great stuff. And I saw here amazing contribution in different SDOs, and that's great. But my feeling is that it's diluted. It's not visible. It's not visible. So AIoT, as you say, is good. We can make it visible. But again, if we start writing something to say we are visible, so we could have indeed a report saying, this is what has been done for all the European projects that we discussed today, and we can have this kind of white paper at AOTI. That's no discussion. I think it would be great, and I think IntellIoT would support that. But this is just, okay, making it visible if we did. The question now is, how can we push stronger? Do we, for example, there are some specific dedicated publications in IEEE standardization activities or things like that, where we could also push or indicate a little bit straightforward. But anyways, okay, there is hands raised, so I stopped talking now.
Anna, you can speak.
Yes, thank you. So I agree with Jerome on his approach, and this is actually what the EU Cloud Edge IoT is trying to do now, that Dave mentioned. And I believe all of our projects here are invited to participate in the continuum, that in this initiative actually that they are trying to do. We were part of some calls, most basically on the architecture task force, where they are trying to produce a white paper there for a general next generation IoT architectural model, which actually takes information from all the projects that have to do with NGIoT, but not in general. They have created different working groups based on different aspects of the architecture. So they have a group on security, they have a group on AI, they have a group for data management, for orchestration. I believe that this is going to work because they also have a lot of meetings per working group to discuss different aspects from different projects. And this actually takes a lot of time for every project to participate in all of the working groups, or at least at 3 or 4 where actually TERMINET is involved, because there are a lot of projects also involved in each of the working groups, but this is a good way to start maybe, because we have a lot of differences, a lot of aspects, really specific aspects in each of the projects that we are trying to standardize or produce something open source. And this is their way to do it. So I think this is a good chance here.
Yeah, thanks. That's quite interesting indeed. So I will have a look into it. But the second point I also wanted to mention is probably, I don't know exactly about your project, but IntellIoT is almost at the end. And end of project is not good for significant contributions. We are all working on prototyping and final things. So the question now is like, that's always the challenge with the European project. And I've been mentioning that a lot of time to project officers, to the fact that we come to the end of the project, we have actually a lot of things that we learned, and then that's it. We have to apply for new project, and that's different people, different topic, different this and that, and it is simply gone. So one of the things that could be valuable to discuss openly with project officers is, if we are notified that we have selected needs for, we have need for contribution to standards, whether there would be a way to have fundings for that and dedicated to that. It's not about, okay, let's make an amazing prototype. Let's use what we had, that we developed, keep it active, and use it to contribute to standards. So it's something a bit different than just saying, oh, let's take a new use case, let's take 6G, let's take this or that. okay, fine, 6G is about it now. It's very cool. This new buzzword, everybody wants to work on it. But let's maybe take what we did with NGIoT and try to see if there is fundings to bring what we think is required to standard, using the platform, keeping it alive, not extending it. I mean, it's kind of I want to seek that I'm going backward, but sometimes I have to feel that we are bound to always move forward, not achieving everything we want to do with what we did, but it doesn't matter. We have to move forward. And if I had to try to do something, I would try to say, let's stop. We can fork. Some project goes to 6G. That's necessary. That's important. But we could also try to consolidate what we did with additional funding using the platform that exists to either use new open calls. Why not? I mean, this is because also I don't know about your project, but our project had open calls, and it was extremely stressful to have open calls. Extremely stressful because the platform is not ready, but people needs to use it. And at the end, we're never really satisfied. The open call people are not satisfied because the platform is not really fully ready. And we are not satisfied because it puts extra stress on us. But at the end of the day, when our platform is done, then the project is over. The moment we are happy with our platform, then the project is over. So it could be interesting to see if I had to say something about, I don't know exactly how we could do that, but standard is important, and there is plenty of things the project can still contribute to standards, but we need to find financial resources. And I don't know, I don't have a solution, but that discussing together and could be part of the solution already.
So mostly standards and sustainability together as a concept.
Yes.
Actually.
Yeah, and I think I saw also a lot of presentation when people said, okay, we put the GitLab. I love that. It's really great. And I remember once there's a project officer that was basically claiming that, okay, now out of these billions of euros provided to Europe, I would like to have a centralized database where I can find whatever has been done in a coherent way, but I can't. I don't know where all these platforms are done, and some platforms are forgotten. And we even forgot, for example, after one cycle, people forget about the platform that has been created, and still useful, but no one knows. So sustainability is important to keep our contributions either in distributed, decentralized GitLabs, but with some kind of place that tells people, okay, these are typical contributions that you can find in individual persons, or if there is a centralized GitLab or GitHub or whatever that would be handled by the European Commission or something that would be sustainable, so that we can keep using it in the future without the risk of having the partner that eventually not maintain it or disconnect it or remove the access to the account. Plenty of operational things if we want to keep it. So yeah, sustainability and standards and money.
Thank you. I guess we can move on through the others. Jens, do you have something you'd like to raise?
Yeah, well, something, I mean, that's mainly because we are coming from the hardware world, but something which I guess sets us apart with relation to the other presentations I have seen is really the standardization on the let's say hardware part is always a little bit, yeah, let's say not really considered from my point of view. I mean, we are doing this, but I feel that especially in European projects, there are not many other people which are doing this from my point of view. Maybe that's because it's not worth doing, or maybe that's because it's yeah, too much at the industry side and not so much on the academic side. With respect to the yeah, comments that Jerome just have, I'm not sure whether a good way to approach such things is to actually, yeah, concretely, I don't know, set up a statement of work or something, which is then so that we find people to work on such things, or is that not the right way to approach these kinds of things?
Good question.
Because that's normally how we started, let's say, working on new standards or things like that. We basically write a statement of work and then find people to have common interest in that. And distribute it across, for example, something like Picnic or SJ or SGET or something like this. Yeah, some more, how to say this in the right way, some more general comments. I mean, open source and standardization, I said that during my presentation, is to me something which is great and goes together quite well on the one hand. On the other hand, it does not always work together, or let's say some of the open source projects do not really care too much about standardization, and some of the standardization bodies do not care too much about open source. So I think that this is also, that's again a more general comment from my side. I think the two things are, from my point of view, made to work together and can work together quite good, but they do not usually do this. I mean, for sure we have open standards. That's true. But those open standards are then not really, or some of them are not really used by the open source projects, and the other way around. So
open source can be considered as a kind of de facto standardization if they're successful, but that's only if there's one approach wins out over most of the others. Otherwise, it's just contributing essentially to the fragmentation.
Exactly, that's what I said during my presentation. We have tried to contribute to the larger project, and I guess that's also a good way to let's say avoid what was said before. I guess it was also Jerome, that things are just dying when the project is over, or that they cannot be found. So as you're saying, it's basically causing fragmentation and establishing standards early, which then for sure can be changed and can be contributed by everyone, would let's say be a way of avoiding too many dead open source projects.
Right. Okay.
I could also just add one thing. Thank you very much, Jens, for the open source aspect. I think one point that is also interesting, I'll be brief on that, is also to agree what we understand as open source. Because there's plenty of different perspectives, depending on you talk to industry or if you talk to people that are from GPL-v3. The US has been operating an audit in open source, what they understand as open source. And because now the government cannot provide money if the software will not be delivered as open source. So if they do that, they need to have everybody has to agree what they understand as open source. So it's also interesting because it could be interesting to show, okay, parts of the project, what are the license we used? Are the license compatible? For example, we use Apache 2.0, which might be not that compatible if we integrate it with another software that is GPL-v3, especially if we integrate that into an integrated partner. So it could be interesting also to have this kind of aspect between projects.
On that point, in a previous project I was involved in, we also had a look at the kind of governance models for these projects, because in some ways, some large companies they support open source. They do so in a way which really supports their business in a way they can control it. So we need to agree on what are good ways of governing such projects.
Yeah, I mean, I had also projects that was not inside of let's say the DG Connect, but more in the Euro HPC, where project officers were saying, well, if you open source it, it will go to the Chinese. So not sure what to say about this.
Yeah.
No, I mean, you think they go to the Chinese, but they already did it, but they just waited for you to expose it.
Okay. Amir, do you have some points you'd like to raise?
I think he went on for the
yes,
lecture.
he went earlier. Sorry, I remember now. Yes, he had to leave after 15 minutes. So, all right. Okay. Theodoros, would you like to say any suggestions on behalf of TERMINET?
Okay, I think one of the ideas. Just a minute, because my daughter is crying. Just a minute to close the. I hope it's better now. I think it was okay. All the points you made, it was correct. I think as one of the next point, I think it was Jerome that mentioned, but maybe we can prepare like a white paper with all the contributions that we have done or something like that. I don't know if this is something that we can do, considering that, as also I think Jerome just said, that most of the projects are in the final months, so we have to act quick in order to do something like that.
Well, that was one of the reasons for asking for recommendations for future work, things that we can carry forward into future projects. So that on our final standardization reports, you want to be able to make some recommendations.
And it's also good to, if we gather to concentrate all these contributions and this recommendation, to try to communicate them to the officers of the different projects in order to see what's the problem, what they can do in order to continue, because as most of you mentioned, okay, it's difficult. I have seen only projects that have big industrial partners. I have seen that made actual something contribution to the standardization because they have the resources, they participate in the working groups, they have a continuation after the end of the project. They have people that are involved only in this task. So from the project, I think it's quite difficult to have something like that. You mentioned all the reasons that why this is happening, but if we can have it as in a concrete, let's say some action points or some recommendations that are related to what EU can do, maybe we can make a difference. I don't know. I think they already know the problem, but I don't know how they can address it. I don't know if someone else from the audience wants to mention something. The floor is open.
I would like to add something else. So we always also face the difficulty of the different kind of partners that we have in the consortium, because when we develop something inside the project, we don't always know if it's going to be an open source tool or if it's going to be something commercial. And if the overall, let's say, framework or platform that we're developing isn't specifically characterized by either commercial or open source, this also causes problems because we have different kinds of partners involved in this endeavor. So this is another aspect that we should also review before at the beginning of each project. Have a clear path of what we're going to do and who will be involved and what the license would be.
I guess we can ask Alex.
Well, from my side, I agree with all what my colleagues have said, especially what Theodoros mentioned. I think the best thing that we can do, I don't know in which moment does the rest of the project ends. Assist-iot ends in March, at least from our side, because of the extension. But I don't know if some of you may finish the next month. So in case that we want to share something, produce something together, it has to be like very quickly. Especially because I guess that you have to, finalize your last round of deliverables and so on, and reports, etc. So maybe some sort of small document with recommendations. Here I have seen that at least 3 partners have shared the idea that federated learning has a lot of room from standards. That's one thing that I have taken from several slides. And I think it's one hot topic that we can recommend, because even some open platforms like Flower that we are using are saying that there are no standards or not well profound standards. So that's one thing that we can put on there. But of course, you may have more ideas from the things that you have researched on, and we can put the things in common in one, maybe not very long document, but something that we can have and share with the offices, maybe with IoT, with you know, as an outcome from ICT 56 projects. Yeah, but as Theodore said.
TERMINET is ending end of January, so okay, we have some time of hand, so we can, I suppose we can work. I don't know about the other projects. Jerome, Jens, you went. What is the?
I mean, this is Jerome speaking. That I would agree with that as well. Different partners in NGIoT developed federated machine learning concepts, and we developed a platform to orchestrate it. So that's would be interested in also, because we also saw that we had to create from scratch.
And when the project is ending?
End of January.
Okay, so the same as us. Okay, thanks.
VEDLIoT also ends end of January.
Okay, so we all have a couple of months. I believe we can work on something.
Well, I mean, what I was proposing is that first of all, if we can get all the slides that you guys presented, and then try and draw up some comments or some suggestions from the notes we've taken and from the slides.
I think Jens has already sent his slides. Okay, we can ask again from Armir. Okay, maybe we can send an email. Just a reminder if they can share the slides, if they are public. Okay, just that.
Yeah, we need to know whether the slides can be made public or not. So that's something there. So, do we have any agreement on sort of how future projects can come together to share better? I mean, is just working as part of like the OTI working group and standardization good enough? Do we want to be able to exploit conferences and have sessions, cross-project sessions? What do you think would work for the future?
Maybe I can make a comment here. And this was already raised as a sub-sentence previously. I think you need to come, or the projects need to come together much sooner, and not at the end, because at the end it's over. It's people will go different paths after at the end of the project and start a new project, and then so you need to. There needs to be a synchronization much earlier for projects,
okay,
for pushing for something together.
That's something we can certainly recommend.
And I think and then one can, I mean, when coming together, and then one can also decide what's the best way, or whether this will be workshop, conferences, or something else. I guess that depends on the domain and on the partners. So I wouldn't. Yeah, I think this is project or partner dependent. What's the best way then to go to synchronize between the projects?
Okay. So it sounds like we're running out of steam. Quick look at these things.
Just to follow up on Felix, maybe as already NGIoT did, it should start by having some meetings per cluster, according to the proposal topics, let's say. So there is already a common ground, but different ideas and different use cases. Regarding the synergies, I mean. For example, for us here, there was the ICT 56 cluster, where we had the basic, the same basic objectives, let's say. So this is a good start, common ground.
And also, if I may add, also with this new CSA that is very active, I think it's also a good idea that it bridges what we have been doing with the new wave of projects. And I think it would be nice also if it continues with the next wave. I don't know, it will be after the meta operating system and so on. But with the next round, it would be good if the CSA continue the integration efforts and so on, because sometimes projects become a little bit isolated. What they do internally don't communicate enough, maybe, as you have mentioned before. So yeah, I think that the activities of CSA, even though they are pushing very much, but we are collaborating more because of that. So I think that's a very good initiative if it continues with this pace.
Okay. Well, it looks like we've reached a reasonable conclusion point.